Hey, fifth graders. All right, so this is going to be lesson 11.3, which is all about quadrilaterals. Quadrilaterals, if you remember from lesson 11.1, are four-sided polygons, which means that they're two-dimensional objects. They've got length and they have width, and they have four sides. So they have they have four sides that meet at vertices and are a closed figure. But these are quadrilaterals. You're going to see me kind of glancing down a lot because I just have the book open in front of me because we're going to kind of go over all of the types of quadrilaterals, and then also I want to give you all the answers there on page 649 and 650, so you can fill that in. I just think that that'll probably help. So quadrilaterals you are probably very used to. In fact, they're probably some of the first shapes that you recognized as a little kid: square, rectangle, that sort of thing, right? So those are two quadrilaterals. They're very specific quadrilaterals, but there's kind of a hierarchy to quadrilaterals, I guess, or there's a Venn diagram that you'll see on the next page that kind of shows you. And this this lesson is one of the lessons that I get the most whining from fifth graders about do I have to write all of the different things? Well, we're not meeting in person, so I guess the answer is it's up to you. However, you do need to be aware of the fact that these things are all interrelated. I'm getting ahead of myself. Let's back up just a little bit. All right, so take a look at page 649. It kind of gives you a chart of a bunch of different, or gives you a whole bunch of different quadrilaterals. The first one there just says a general quadrilateral has four sides and four angles, which you already knew from lesson 1. Okay. Now, if we take a look immediately to the right, is a parallelogram. Okay, parallelogram has opposite sides that are congruent and parallel. So when we talk parallel here, what we mean just is two line segments, or lines really, on a plane that extend forever and never meet. Okay, so these two lines will never meet, even if we extend them out. Obviously, these two lines probably would because I can't draw them properly, but we assume that they are parallel. Okay, little looking ahead at things that you'll have to know later, that means that if I drew a line through here and it was a right angle and it came down here, then it would also be a right angle down there. Okay, that's not a big thing for you to know, but it kind of does start to set up our rectangles, right? Okay, notice there's a rectangle in here. Okay, so but we are talking parallelogram. Actually, you know what? Before we talk parallelogram, I'm sorry, let me back up. So my book is a little bit different than yours. I always kind of joke with the kids that King Pemdas decreed from on high that a parallelogram is actually a trapezoid. So we're going to actually jump down. I'm not sure if your book is the same as mine. My book is wrong. But if you kind of jump down to the lower right-hand corner is where it should say trapezoid. If it's not in the lower right-hand corner, then just find the word trapezoid somewhere on page 649, and that's what I'm talking about. Should have a picture that looks something like that. Okay. It might not have these little squares in there, but that's okay. All right, so a trapezoid, in fact, it doesn't even necessarily have to have those squares there. This could easily be something like that, is still a trapezoid. Okay. The big key here is that these two lines are parallel. Okay. So a trapezoid is a quadrilateral that has at least one pair of parallel sides. Okay. My book says exactly, and that's where the difference is. If it's exactly, then this shape and only shapes like it can be trapezoids. However, if it's at least, then that means that everything that has at least one set of parallel sides is also a trapezoid. So it kind of changes a lot of things. All right, so this is a trapezoid, right? At least one set of parallel sides. Now we're going to talk about a special type of trapezoid, which is called a parallelogram. A parallelogram is a special type of trapezoid that has two sets of parallel sides. So these here are parallel, and this one, and this one are parallel. Okay, so it's got, so parallelogram is two sets of parallel sides. Okay, now notice I haven't said anything about the angles, right? This doesn't have to be right angles. This doesn't have to be a rectangle. If you think about making like, you know, a rectangle and then you kind of like push it over a little bit, right? Some of those angles change. Okay, that's kind of what I'm doing here. Okay, this could just as easily have been like that. Hopefully you can still see that. It's kind of up in the light. All right. If I adjust this. Nope, that doesn't change anything. All right. Let me erase and bring it down here so you can see a little better. Okay. So it could just as easily have looked. Let's make it even more extreme. Something like that, as long as these two sides are parallel and these two sides are parallel, which my drawing is terrible, so they're not, but it's still, if they were, then that is a parallelogram. Okay, so moving along, we have our next shape, should be, I believe, a rhombus. Again, I'm going off a book that's probably a little bit different than yours. So a rhombus is a special type of parallelogram. In this case, it is a parallelogram where all the sides are equal, or they're all congruent. Right? So these two lines and these two lines are parallel to each other, and all four sides are congruent. Make sense? Okay, so this is a rhombus. Now, if we have there's another type of special parallelogram, which is called a rectangle. You guys all know what a rectangle looks like. Okay. Now, notice these sides are parallel, and these sides are parallel, but they're not the same length. So this is not a rhombus. However, it is a parallelogram, and all four sides have the same type of angle. So a rhombus is a special parallelogram with four right angles and four pairs of parallel sides. Oh, actually, well, sorry, four sides or four sets of perpendicular sides. So a perpendicular line is a line that comes down and meets another line at a 90-degree angle. Okay, that's a perpendicular line. So in the book here, they want you to be aware of the fact that this line is perpendicular with this one is perpendicular with this one's perpendicular to this one, et cetera, et cetera. So basically, they have to meet it at 90-degree angles, which is, you know, what is implied by the whole fact that there's four right angles. But also, because it's a parallelogram, that means that this side and this side are parallel, this side and this side are parallel. All right. So now we have a special type of parallelogram that's also a special type of rectangle that's also a special type of rhombus, and that is a square. So a square is a special, all those things. Basically, the way I've described this in the past is that if a rhombus and a rectangle had a baby, then it would be a square, right? Because it's got the four right angles of the square, or of the rectangle, and it's got the four congruent sides of the rhombus. Okay, so this is just a special everything. It is the most special of all the parallelograms, or of all the quadrilaterals. So, but notice the square is not just a square. What else is it? Well, it's a quadrilateral. Right? And in addition to being a quadrilateral, because it has at least one set of parallel sides, it's also a trapezoid. And it's not just a trapezoid because it doesn't just have one set of parallel sides, it actually has two sets of parallel sides. So that means that it's also a parallelogram. I think I misspelled that, but whatever. I did. This first one's supposed to be 2. Spelling is hard. Okay, so it's a parallelogram. But in addition to being a parallelogram, it's got 4 equal sides, so it's also a rhombus. But in addition to being a rhombus, it's got 4 right angles. That means that it is a rectangle. And because it has 4 right angles and 4 parallel sides and 4 congruent sides, that means that it is a square. So if you wanted to very specifically name this shape, you would say that it's a quadrilateral, trapezoid, parallelogram, rhombus, rectangle, square. Fun, right? Well, that's what you're going to be doing in this lesson. So when you get to questions 4 through 7 on page 651, and then 2 through 6, yes, 2 through 6 on the homework, it's going to ask you to name these shapes, right? Basically classify the quadrilateral in as many ways as possible. Well, if you have a square, this is all the ways that you could possibly classify it. If you showed me this shape and you said, what is this shape? And I told you, well, that's a trapezoid. You might say, no, it's not, but it is a trapezoid. It's also a quadrilateral. It's also a parallelogram. It's also a rhombus. It's also a rectangle. And of course, it's a square. It's just kind of how it works. So I was going to go through page 650, but it occurs to me that I probably won't be able to do that because I don't know what yours looks like. Mine looks like somebody who didn't know what they were doing made it, but that's okay. I think, if I remember correctly, that it's got a whole bunch of circles. So it's got kind of like a big circle, and this is quadrilaterals. And then inside of the big circle, and there's probably like some shapes here that are, like that, something like that. And then inside of this, we have trapezoids. Right, and you might have something like that. Okay, and then inside of that, you have parallelograms. And then inside of that, you do not have a big circle. Sorry, this is where it's probably looks something like that. And I bet you one side is rectangles, and the other side is rhombus. And then right beautifully in the middle is square. So notice that square is still inside of the quadrilateral circle. It's inside of the trapezoid circle. It's inside of the parallel, all of those, right? So you can have rectangles here, right? So that rectangle is also a parallelogram, a trapezoid, and a quadrilateral. But it is not a rhombus, and it is not a square. Okay, same thing over here. All right, this rhombus is a parallelogram, a trapezoid, and a quadrilateral, but it is not a square or a rectangle. Okay, so hopefully you can see that. I just realizing that there's glare right there. That word is quadrilateral. I'll write it down here too. So to all of you who are perhaps groaning about the fact that you have to write all of these words and it's so hard, it's only, I guess it's 2 through 7, all right? So it's 6 whole times that you have to write all of the words, plus maybe 1 or 2 other times. It's not that bad. You can handle it. But if worse comes to worse, just, use some abbreviations or something. The big thing that I want you to do is know that these words are, that these shapes are not just themselves, but they are all these other things as well, okay? Like the big idea here is that a shape that's inside of one classification can be inside of multiple other classifications and still be the same shape. All right, that's it for quadrilaterals. Good luck on the homework. Of course, as always, let me know if you have any questions, and I will help you out as best I can. All right, have a good day. Bye.